I wanted to start by talking about, what's happening in the world today. And the big news right now is the airline that is lost. And I don't know how many of you noticed that, but with the entire world looking for this aircraft, it's US technology that's at the forefront. The finger locator is developed by a company in the outskirts of Washington, D.C., and also the vehicle that's going to go down to look for potential debris is also produced by the same company. So when you have worldwide technology being deployed to search for this missing craft, U.S. innovation engine is the one that is featured, that's out there. It's on a Australian craft, but it is U.S. technology that's right there. So we have led in the last century the technological innovations around the world. And the question is, are we going to remain the technological leader in the 21st century? And our innovation engine is fed by our education pipeline. We heard a lot of discussion this morning about the education pipeline. Certainly, we produce those graduates, those STEM graduates out of our universities that later go on to produce the things that we all use, the iPhone, Facebook, the finger locator amongst them. So it's a very important question. We've come through the Great Recession now, and we're looking forward to a growth rate of 3%, perhaps. We'd be all happy to have 3% growth annually as a U.S. economic growth. However, in the STEM area, in 2012, there were 7 million jobs. By 2018, we expect it to be 8 million jobs. So a much higher growth rate, perhaps 2 to 3 times the growth rate of the U.S. economy in the area of STEM jobs. Why is that important? Well, one of the important things is that in this Great Recession that we went through, people are talking about a structural unemployment problem. This is not like some other recessions that we've had in the past where the economy improves, jobs are created. We are essentially de-skilling the jobs. They are being automated, they're being outsourced. So what's left then are the jobs that really require a high degree of capability, and a lot of these are STEM jobs. In fact, even more to the point, of the STEM jobs, 71% of them are in computing. So it's really important to understand where these jobs are coming from. What are the jobs that the United States will have in the next decade, in the next 50 years, in the next 100 years? They really are associated with STEM jobs. So what are the barriers to getting people interested in STEM? And I'm going to give you some examples of that. I like to deal in stories, so I'm going to tell you a few quick stories to understand this. But let's start with some math, first of all. 25% of the college graduates select STEM disciplines as the area that they'd like to graduate in. Less than half of that, 40%, actually graduate after 6 years in a STEM discipline. So most of them either drop out of college or drop out of that STEM major that's there. Fortunately for us at NC State, that number is much, much better. 50% of NC State's graduates are majoring in STEM disciplines, which is very good to know. Why is it that we don't do that? Well, so here's the first story. I'm going to talk about 4 different points here. First story is about age. When I was in Louisiana, they had a 3rd grade textbook that had a picture of me in there. That's, one of the odd things that happen in life. And I was featured as a local entrepreneur, possibly to encourage young girls to go down the path of innovation entrepreneurship. So whenever anybody in my friend circle's daughter was in the 3rd grade, I'd get a request to come to her class, because that was really a big deal for that child, that somebody that was in their textbook would be there. And it was one of the most delightful things that I did over the years, is to go to these 3rd grade classes. It was wonderful. The children were engaged. They had so many questions. I'd tell them a short story about what I did, and out would come hundreds of questions. They were intelligent questions. They were probing questions. At the same time, people asked me to come and talk to high schools that were looking at career paths, and it was just the opposite. People did not want to ask questions. They looked embarrassed. They looked down. It's like the education was falling off their heads, literally, because their heads were down. and they were not going to take in any information. So what do we do to them between the third grade and high school that we have that kind of an effect? And I think we should look at, when we look at K to 12, we should consider what we are doing to disengage the students and their natural curiosity from the third grade over into the middle school and the high school years. And that's, I think, a critical challenge. The second one is a gender issue. This is important for me because I think that there's a real problem in STEM education in attracting women to STEM disciplines. So in the 1980s, about a third of the STEM graduates were women. By the 1990s, it was a quarter of them. And in the 2010s now, we are at 17%. So at the same time that women are going to universities at a higher number, higher percentage of graduates of universities are women, more women are enrolling than men, we have this decline in women going to STEM education. How do we contain that? I'll give you a nice story of how this was contained, at least at one college, Harvey Mudd College in California. Notice that the number of graduates of the programming classes was predominantly male, that women were not taking these classes. So in about 2006, they said, let's go ahead and change how we teaching programming. And instead of saying introduction to Java, they said creative problem solving using programming, using Python programming. Why Python and not Java? Well, Python is more forgiving programming language than C or Java. And so it gives a ramp up to get involved in programming. At that time at Harvey Mudd College, 10% of the class for programming classes was women. By the time, recently, like 2012, 13, what do you think that happened? 6, 7 years. Guess at what percentage of women were enrolled in programming classes at Harvey Mudd? Anybody want to take a guess? Maybe double, 20%? Well, try 40%. So it went from 10% to 40% entry of women into the programming classes. They did some other things. It was not just reformulating what they taught and how they characterize it, but they took the women professors, took the women students to Grace Hopper conference so that they could see other women, understand that Admiral Hopper, who was such an important figure in our defense forces, was a early pioneer in computing, and encourage them to also develop practical applications of what they were learning in the areas that they were interested in. So those few interventions really resulted in a fourfold increase in the number of women in those classes. I'll give you the next example, the third story of this. Actually, it's going to be 2 stories under this one heading, but it's the word STEM itself. And I have been talking about this now for a couple of years. I think we need to add another S to it, for STEMs. What am I talking about? I'm talking about the social sciences. And then you might say, don't talk about that, but I think it's very important. And I'll give you 2 examples of why it's important. First of all, when I talk of social sciences, I'm not talking about social sciences in terms of literature or the arts. Those are very important. However, that's not what I'm talking about. I'm talking about quantitative social sciences, things that help us understand the world around us in a more quantitative fashion. So here's the first story. In 2004, we were hired by FEMA to develop a exercise to look at what would happen if a catastrophic hurricane struck New Orleans. We developed a modeling and simulations product called Hurricane Pam that was a fictional hurricane striking New Orleans, and used mathematics and engineering to figure out how many people would be affected, how many people would die, how many people would be homeless, how many people would need rescue. All of that was done through a series of computer simulations. That data in 2005, the next year, when Hurricane Katrina struck, was a scientific bullseye. It was almost precisely what we had predicted. And I spent 2 months of my life dealing with the national and international media, and I would not recommend that. as an activity for anyone, and testified with Senator Collins and Senator Lieberman's Senate Committee on Hurricane Pam and how we had predicted that. However, as good as the prediction was, it was not able to propel the right actions and decisions. At the time of Katrina, it was known to the state, it was known to the city, it was known to the federal government, yet we had the chaos that we had during the response and certainly the early recovery from Katrina. So where does that put us? STEM succeeded. STEMS did not. It was a social science aspect of how to get people to collaborate, how you get people to work together, and how do you change human behavior that failed in Katrina. And I think that's something that we need to learn more about. I'll give you another example. Yesterday, I saw an article on the tsunami in Japan that happened, the Fukushima earthquake and tsunami. And as you know, there was an enormous loss of life associated with that storm. Over 20,000 people died from the tsunami. Well, Japanese researchers looked at who died in which communities and why they died. Well, of course, if you had more water that came in faster, people died at greater rates in those communities. But accounting for that, they found a very curious phenomenon. The mortality rate varies from 2% to 10%, depending on social capital. So the communities that were socially integrated were able to take care of each other and respond to the tsunami, resulting in a substantially lower rate of mortality versus communities with similar situations in terms of the height of the storm surge had a much higher mortality if they didn't have enough social capital. So I think that in this particular century, we are going to tackle one of the thorniest problems that we have faced, the most difficult material on this planet, which is the human mind. And this is a new frontier. In economics, there's behavioral economics. And in a lot of the disciplines that we deal in, Homeland Security, emergency management, is really dealing with the people. And as I like to say, under carefully controlled circumstances, people do damn well what they please. So you've got to understand what the human person does in a certain situation and develop policies and systems that would go with the grain instead of going against the grain. So I would say that we should really think about expanding out there and adding that S to it and looking at these quantitative social sciences that help us understand human behavior. And then the fourth thing I would say is that there's a revolution occurring in education. And this revolution, this is MOOCs that I'm talking about, massive online open courses. And my son, who graduated about a year ago and is in the process of launching his company, which is an education-based company, but I'm not going to use this opportunity to plug that. The reason for that is, the reason I'm bringing him up is because he is out in San Francisco taking courses, and he decides to take a course and goes to take that course and says, okay, I need a prerequisite, I'll go to another university. So he's working on Udacity or Coursera. It's open to him with whichever place he wants to go, wherever the best courses are. He doesn't have to go through the whole process of sending in the application, writing essays and things like that. The courses are very structured. It's not just an online education. It's really designed for how a person, a student, thinks. So one of the things that I found out is that you learn a little segment, and then there's a test. You take the test, and it tells you are 10% done towards this course. And it's really encouraging and creating a slippery slope towards completing what you're trying to do. And it's using every little bit of knowledge that we have about how human beings react in certain situations to produce that end result, which is a successful completion of that course. And I think that this revolution, if we don't get on board in our universities with this revolution, when the whole education system becomes Amazonized, let's say, then we'll be like the booksellers that no longer have, it's quaint to have a bookstore. Most people go to Amazon and ebooks now. in increasing fashion. So something that we should think about in our education pipeline, in our education process, in the production process, that the whole production system is changing, and we need to be the vanguards at the front of this train, not be following behind. There are some things that we're doing that are great. The Institute for Advanced Analytics here at NC State is a great example of that. A system that's designed to produce graduates for the big data movement that's going on in various areas. I know I can tell you that we've been trying to hire their graduates and have not succeeded, because every single person before they graduate has a job, and you can't touch any of the people that are in the course unless you get in the pipeline and wait. And isn't that a wonderful thing for people to have, is that employers are waiting to hire an employee coming out of a system. That's fantastic. So where do we stand? I'm going to summarize that by saying we are about 15th to 17th in terms of STEM jobs in North Carolina. We need to be in the top 5. And that's just counting the United States. And really, as speakers have said before me, the challenge is global. So we really need to head towards the top of the heap for the United States and for the rest of the world. We have a great brand in North Carolina. We have great partners. We have great collaborators within the state, from academia, from industry, from government. And we really need to figure out how we get to the top 5 within the United States. And also encourage certain things that are going on. I'm just going to mention a couple of them. One is that AT&T has just announced, I don't know if you saw this morning, that they're considering this area for their gigabit network, which is going to be fantastic to have that. And Google Fiber is also looking at this area to potentially put same 1 gigabit per second network, which will give us a great competitive advantage in this computing-based industry and the computing-based century that we are heading towards. So there are great things that we are doing. Let's look at where we can get lessons learned from other places. Let's create our own unique innovation here so that we can be leaders in this century for the STEM's job of the future. Thank you.